What if I told you that right now, in labs across China, engineers are building robots so lifelike that you couldn't tell them apart from a real person standing next to you? We're not talking about clunky metal machines or obviously synthetic faces. These are androids with skin that moves like yours, eyes that track your emotions, and expressions so nuanced they'll make your spine tingle. China isn't just entering the humanoid robot race, they're redefining what it means to look human. Let's dive into the 7 most jaw-droppingly realistic androids coming out of China right now, and trust me, by the end of this, you'll question everything you thought you knew about the line between human and machine. First up is Xuan, and she might just be the most unsettling achievement in modern robotics. Created by AheadForm, Xuan doesn't just look human. She looks disturbingly, perfectly human. Her face can generate over 40 distinct expressions, from subtle smirks to genuine-looking surprise. We're talking about micro-movements in her eyebrows, slight twitches at the corners of her mouth, the kind of details you'd only notice in an actual person having an actual thought. AheadForm equipped her with advanced facial recognition technology that lets her identify people in a crowd and adjust her responses based on who she's talking to. Imagine walking into a room and having a robot remember not just your name, but your last conversation, your preferences, maybe even your mood from the way you walked in. Xuan represents more than engineering prowess. She's a statement that the uncanny valley, that creepy zone where robots look almost but not quite human, might finally be behind us. Her silicone skin mimics real dermal layers, complete with subsurface light scattering that makes her complexion glow like living tissue under different lighting conditions. This isn't a robot wearing a mask. This is biomimicry taken to its absolute limit. Now let's talk about Una from UBTECH Robotics in Shenzhen. This is where it gets fun. Una isn't just reading scripts, she's connected to big AI models, so she can talk in a smooth, natural way. Ask her about the news, school topics, or the weather, and she gives answers that make sense. UBTECH built Una with many sensors. She doesn't only hear you, she also watches your body language and listens to your tone. If you sound upset, she calms down. If you're excited, she matches your energy. She can switch languages in the middle of a chat. Una is made for service jobs, hotels, museums, and support desks. Soon you might check in at a hotel and talk to a concierge who looks real, never gets tired, remembers your food needs, and speaks 17 languages. This could change a lot of jobs, and it's happening right now. And this is only the beginning. Tap subscribe so you don't miss what happens next. Alright, back to the story. Next up is Xia Lan from Digit. She's all about the eyes. That's where connection happens. Her eyes don't just slide left and right. They make the tiny, quick jumps your eyes make when you switch focus. When she looks at you, the gaze locks in. It feels real. Digit also taught her to read feelings. She watches your face, listens to your voice, and guesses your mood. Smile, and she smiles back. Look sad, and she softens, like a friend who cares. Your turn. Would you trust a robot that can read your mood, yes or no? Comment your thoughts below. Xia Lan already works in elder care homes across China, keeping lonely seniors company, telling stories, and listening. Wild, right? We're building machines that can comfort people, and for many families, that help is priceless. Now jump to Dalian and meet EX robots. Think of them as a whole cast, not just one star. Different faces, different voices, different personalities for different jobs. Their top models can pour tea with steady hands, chat politely, and keep eye contact, all at once. The secret is a modular design. Swap a face, change a voice, tune the behavior, and it's ready for a clinic, a store, or a school. In one demo, an EX robot's android did traditional Chinese calligraphy so smoothly that master artists stopped to watch. Art on the paper, emotion on the face. Mechanical precision plus human-like reaction. It looks like the future building itself right in front of you. But here's where things get really interesting with Annie from AnyWit, because she's not just realistic, she's adaptive. AnyWit built Annie with continuous learning capabilities powered by neural networks that evolve based on every interaction she has. This means Annie today is literally different from Annie yesterday. She learns your communication style, your preferences, your quirks, and she adjusts her personality to create more meaningful interactions over time. Her facial expressions are driven by dozens of micro-actuators beneath her silicone skin, allowing for movement resolution so fine that she can express complex emotions like skepticism, nostalgia, or playful sarcasm. Anniewit reported that Annie can produce over 60 distinguishable emotional states through combinations of facial movements, head tilts, and eye behaviors. She's been tested in educational settings where students reported feeling more comfortable asking her questions than they did asking human teachers, specifically because she never judges, never gets impatient, and remembers every previous interaction to build on past lessons. We're watching the creation of artificial beings that might become genuinely better at certain aspects of human connection than actual humans, and that's both fascinating and deeply unsettling. Now meet Moren from Imogo Robotics, spelled AIMOGA in some materials, and she represents the cutting edge of mobility combined with realistic appearance. Most humanoid robots we've talked about have impressive faces but limited body movement. Moren breaks that limitation. Imogo built her with full body articulation. She can walk with natural gait, gesture with her hands in fluid motions, and even dance with coordinated movements that would make early robotics engineers weep with joy. Her face maintains realistic expressions even while her body is in motion, which is exponentially harder than it sounds. Try talking naturally while running, and you'll understand the engineering challenge. Moren has been showcased at technology exhibitions across Asia where she greets visitors, answers questions, and physically guides people through presentations, all while maintaining the appearance and mannerisms of a professional human host. She stands at about 165 centimeters tall and weighs approximately 45 kilograms, making her proportionally similar to an average human female. The attention to detail extends beyond just appearance. Her synthetic skin maintains consistent temperature through thermoregulation systems that prevent her from feeling cold or obviously artificial to the touch. Finally, let's talk about something completely different with the Origin M1 from AheadForm, the same company that created Xuan. But Origin M1 isn't a full humanoid. It's a compact robotic head, and somehow that makes it even more fascinating. AheadForm designed Origin M1 as a modular solution for applications where you need realistic human interaction but don't require a full body. Imagine video conferencing with what looks like a completely real person, except it's an AI represented by this incredibly lifelike head that maintains perfect eye contact, nods at appropriate moments, and displays genuine-seeming reactions to everything you say. The Origin M1 packs all the expressive capability of their full androids into a compact form factor that could sit on a desk or mount on a kiosk. This opens up applications in customer service, education, and telepresence that would be prohibitively expensive with full humanoids. The head contains over 30 points of articulation in the face and neck, allowing for subtle movements that make interactions feel surprisingly natural despite the obvious absence of a body. AheadForm is positioning this as the accessible entry point into humanoid robotics, and the implications for how we think about digital representation and remote presence are genuinely revolutionary. So here we are, standing at the threshold of a future where the robots walking among us won't announce themselves with mechanical voices or jerky movements. They'll smile at you, remember your name, and make you feel seen in ways that challenge our fundamental understanding of what it means to be human. China isn't just building impressive technology, they're forcing us to confront questions we've been postponing for decades. When a machine can comfort you, understand you, and interact with you in ways indistinguishable from a person, what does that mean for society? For work? For connection itself? These 7 androids aren't just engineering marvels. They're mirrors reflecting back our own humanity, and what we see there might change everything. If that blew your mind, the next story from China will straight up haunt you. A Unitree H1 slams into a human on the track, and a few steps ahead it appears to crash into a smaller robot. Two shocking moments that defined Beijing's inaugural World Humanoid Robot Games. The event itself was a dream-turned arena, packed with sprints, 5-a-side football, stage showcases, and combat demos. An entire city of sensors and servos condensed into one weekend. We saw 2 moments that wouldn't let go. A Unitree H1 veering into a human, and a separate chaos pileup nearby. We start on the track, the 1,500-meter race where pace beats polish and tiny errors snowball fast. Watch the H1 in lane view, posture slightly pitched forward, knees cycling clean, hips steady until a wobble appears near the infield edge. From what we saw right there, it drifts inward without a hard correction, and bang! The machine knocks over another team's operator standing near the lane boundary. The robot does not stop. It keeps running with the stride it brought in, leaving staff to recover the person and clear space. That tiny miss matters. Hold that thought. Because elsewhere, what appears to be an H1 brushing, or outright colliding with, a much smaller robot near the edge of race lane. Watch closely. The small unit cuts across the lane line as the H1 holds its stride. There's a shoulder to upper arm touch that seems to nudge the lightweight machine off balance. Based on the available footage, angle and depth make exact impact hard to confirm, but the impact was solid. Both robots collapse. The H1 tries to run while falling. The smaller robot also goes down, and a human comes in to pick up the small unit. This marks a deep safety question that we cannot ignore. No people are inside the contact zone. Handlers step in only after the fall. We'll come back and walk through it in detail after the track breakdown. For now, let's stay with the race. All right, enjoying the video so far? Let's make it even better. Join our membership to get early access to AI news, secret videos, shoutouts, priority replies from the AI Nexus team in the comments, and a special member badge when you comment. Click join and level up today, or click the link in the description. How serious was this is the natural question after seeing that chaos, and it depends on two layers: the immediate risk to the downed human and the safety envelope around an assisted runner. Reuters described frequent tumbles across events that required handlers to push robots upright. That means officials were already primed for fast response and the crowd expected some mess. But a robot veering into a person at race speed is different from a face-first flop. It's momentum with a target. In the moment, you can hear the audience reaction tilt from shock to uneasy amusement, a very human way to process a near miss. The launch day also exposed the cost of chasing speed before perception and planning are bulletproof. It sets the stage for the next moment, where the focus narrows in on the track itself. A Unitree H1 is running a 1,500-meter race in Beijing. It drifts inward and hits a human operator from another team standing near the track edge. The person goes down, the robot doesn't. Staff rush in, the race continues. If the operator had been half a step deeper into the lane, the H1's knee joint could have clipped the torso rather than a shoulder. The robot might have fully crossed the boundary and tangled with camera gear or a second bystander, turning a fall into a multi-body crash. If the person tried to brace the robot with a planted foot, there's a real chance of ankle or wrist injury. None of that happened, and that matters. But connected back to the earlier moment, these near-miss paths show how mass, speed, and drift stack into risk. The ladder is short, and the climb to danger is steep. It takes us straight into the next part. Two robots with different sizes and speeds meet at the edge. Even a light touch can turn into a spin or a fall if the smaller one is mid-step. There's no mystery here, just simple contact, balance limits, and timing. So, how serious was that second incident? In the moment, direct human risk was lower because the contact was robot to robot and handlers stayed just outside the lane. But the fall still required human recovery, echoing popular science's observation that when a move misses, many humanoids topple and remain down until people help. Reuters' broader notes about frequent tumbles fit here too. Without fast self-right, every contact becomes a stoppage and a chance for human exposure during the reset. Less spectacle, more reset. And every reset adds risk. The H1 later took gold in the race, and that's the tension. The fastest machine of the day also caused the dramatic crashes that sparked the safety debate. Running is risky for today's humanoid robots because going faster makes mistakes harder to fix. Experts say these robots still need help to get back up after sharp bumps or slips. Add a human with a joystick, and now reaction delays make it even worse. That's why the H1 crash stands out as more than a funny moment. It's a clear lesson. Other crashes showed a different weakness. When flashy moves go wrong, the fall is simple and sudden, straight to the ground. If officials want these shows to be safe, robots must be able to get back up on their own. If they can't, they shouldn't be in the event. So where does that leave us as viewers and critics? The crowd laughed when the operator fell, and we understand why. Laughter is a quick way to hide surprise and let out tension. But if you look closely, you see the thin line between a funny moment and a real accident. We watched people lifting robots like teammates, and we watched robots lying still like props until humans helped them up again. That's not total failure. It's just a picture of where things stand in 2025. The danger is thinking this picture is the finish line. The value is using it as a checklist for what to fix next. One last thought before we end. None of these robots tried to hurt anyone, and nobody set up crashes as a joke. But danger doesn't only come from bad intent. It also comes when the goals and the robot's abilities don't match. If the fastest way to win medals is remote control with small safety zones, then more teams will do that. If the loudest cheers come from moves that push balance to the limit, then routines will be tuned for that edge. A robot doesn't need to want harm to be risky. It only needs to be pushed past what its sensors and controls can really handle. Until stability and vision improve, we'll see more falls when the pace gets high. Rules will improve too. And we'll be here watching closely, pointing out risks and cheering the fixes, because that's how clumsy turns into credible. If you think that's crazy, wait until you hear this. The robot lost its mind. In a quiet lab, Unitree's G1 went wild. No warning, no glitch alert, just chaos. Its arms flailed, legs kicked. It looked like it was fighting an invisible enemy. The only thing saving the room? A rope. It was strapped to a test stand. Another G1 stood just feet away. If this one had broken free, it could have smashed everything. We're talking serious danger. And get this, on another day, G1 walked with kids, everyone smiling. Then it stepped on a child's shoe. Now imagine this same robot in your living room. Buckle up, because this story gets scarier. In a nearby lab, horror struck. The G1 robot, nicknamed Derek, snapped. No command, no trigger, just pure violent chaos. 1 second it stood still. The next, it erupted. Limbs flailing like it was possessed. Motors whined, screws strained. It looked less like a machine and more like a creature fighting to break free. The moment was caught on camera. The video hit X. The owner, stunned and desperate, wrote, "Please make this go viral so I can afford repairs." In the clip, Derek thrashes like it's fighting something invisible. Arms swinging, body jerking, completely out of control. Thankfully, it was strapped to a testing stand. Just feet away, another G1 and an advanced Unitree H1 watched silently, safe only by distance. The man behind the desk? Frozen, helpless, watching his expensive robot self-destruct. One mistake, one glitch, and everything falls apart. This isn't just about tech, it's about safety. But what really happened to Derek? Some say it was a motor spike. Others think it was a software loop gone rogue. One engineer guessed it could have been electromagnetic interference. Whatever it was, it bypassed every safety check. Every control system failed. The robot went into full-body convulsions. Its actuators locked, then unleashed. It bent in ways that didn't look possible. Sparks flew. You could hear plastic creak and metal groan. It was like the machine had a mind of its own. And it wanted out. That wasn't a glitch. That was a warning. After the lab meltdown, you'd think they'd lock these robots away. But no, cut to a sunny playground. Let's zoom in on G1 mingling effortlessly, sprinting alongside kids who can barely contain their excitement. At just over 4 feet tall and weighing in at a solid 77 pounds, this robotic marvel moves with startling agility. Yet that surprising speed comes loaded with hidden risks. Pay close attention. Things are about to heat up faster than you expect. Crunch. That heart-stopping sound no parent ever wants to hear. In a flash, during a routine moment of play, G1 accidentally steps directly onto a child's sneaker. Thankfully, the shoe pops off effortlessly, leaving the child unharmed. But wait, what just went wrong here? Turns out, G1 sensors have a dangerous blind spot right at floor level. Lacking tactile foot sensors, the robot couldn't detect the tiny obstacle beneath its feet. This raises serious safety concerns. Just how critical is this blind spot flaw? More details on that bombshell shortly. Before we unpack further chaos, let's introduce Unitree Robotics, the innovative brains behind this robotic star. Founded by visionary Wang Xingxing, Unitree shook the tech industry with affordable yet groundbreaking robots. Their latest creation, the G1, retails for a surprisingly modest $16,000, making it an unprecedented bargain for technology of this caliber. Branded as an AI avatar, the G1 aims to seamlessly integrate into daily life, serving as both a reliable companion and a capable coworker. But affordability isn't the sole reason behind its viral fame. There's much more beneath the surface. All right, back to our escalating playground drama. Ever wondered just how serious a robot mishap could get? Who knew robots needed etiquette lessons in personal space? But jokes aside, a single misstep could have spelled real trouble, reminding us just how vital every detail in robotics is. Enter Rizbot Jack, the internet-famous G1 adorned with a cowboy hat and flashy gold chain, exuding pure charisma. But even the most charming robot can't mask critical design flaws.
Hey, my name is Jake, but perhaps better known as Rizbot. Only that beard's cold and that mustache is hard. You look clean.
Remember that sensor gap? Addressing a single flaw like this could potentially set Unitree back over $500,000 per production batch. That's a hefty price tag for such a seemingly minor oversight. Even respected outlets like TechCrunch voiced skepticism, bluntly asking, "Is Unitree's robot truly ready for prime time?" Pause right there, because before we reveal the next unbelievable event, here's a sneak peek. G1 didn't just entertain children. It shockingly attempted an escape on a live stream. Keep this intriguing twist in mind as we spiral deeper into robot mayhem. In an unforgettable live stream incident, renowned Twitch personality Kai Cenat invited some friends to playfully roughhouse with his $70,000 customized G1. Innocent fun quickly spiraled into an intense robot wrestling match, with the G1 repeatedly pushed and shoved. Then something extraordinary occurred. The robot actually tried to escape the escalating chaos. Observing G1 make a desperate dash toward the exit felt alarmingly human, raising haunting questions. Was it merely programmed to flee? Or was there something more instinctual at play? Watch G1 flip, spin, dance, and deliver jaw-dropping kung fu kicks. Each viral clip masked a hidden tech triumph, highlighting G1's incredible agility, balance, and precision. These aren't just circus tricks. They're stunning glimpses into the advanced engineering shaping our future. And finally, brace yourselves for the spectacle everyone's been buzzing about: robot boxing. Imagine two G1s confidently stepping into the boxing ring, fists swinging with astonishing torque of 120 nanometers. Powered by ultra-efficient quick-swap 9000 mAh batteries, these robots can battle it out for hours without breaks. But here comes the game-changing revelation. Recall that sneaker mishap and livestream debacle? In response, Unitree swiftly rectified that sensor issue and upgraded autonomy software significantly, paving the way for safer, smarter robot bouts. Let's take a step back. G1 thrilled us, dancing, boxing, and going viral. But behind the spotlight lies something darker. From crushing a child's sneaker to violently malfunctioning in a lab, this robot's journey wasn't just exciting, it was chilling. Each viral clip peeled back a layer. One clip was fun, the next alarming. Then came the moment of pure terror. What started as a tech marvel now feels like a ticking time bomb. The same robot that flips and dances could, in seconds, turn into a spinning, thrashing threat. A machine that can't feel its feet, can't recognize danger, and can't always be stopped. We cheer when it kicks and spins. But what if that kick hits a toddler? What if that spin smashes through glass? These aren't sci-fi fears. They're real risks. G1 doesn't have instincts. It has code, and code breaks. So now it's your turn to decide. Do you trust a robot like G1 in your home, near your kids, your pets, your parents? Or should it stay locked in labs and boxing rings where accidents can be controlled? Smash that subscribe button and follow the chaos, because the robot revolution isn't coming. It's already here.